Part B of this one, very similar, but this time we're going to the power of 5. So these can get quite long if these values go up quite much more. So cos to the 5 theta, and then continuing using the binomial expansion, as cos to the 4, I'm going to stick the I in there as well. And then I'm going to have cos cubed and sine squared. Now, of course, there's an I there, I squared, so that's going to be minus, and the next number in the Pascal's triangle for that is 10. So then we've got another 10 here. Now we've got cos squared, and we've got sine cubed here. And there's an I cubed coming in here. I cubed is minus I. Next one's going to be a cos theta and a sine to the power of 4 theta. And that's going to have an I to the power of 4. I to the power of 4 is just 1. So there is a 5 coming through here. And the last one at the end there would be sine to the power of 5 theta. And there's an I to the power of 5. So we just want an I in front of that. I've missed the plus out there as well. Now, denouement from all of this would give us cos 5 theta plus I sine 5 theta equals, and I won't write all that out again this time, so we've just got all of that. What are we going for again? We're going for a sine part again, so we're just going to take the imaginary parts again. The imaginary part of this one is sine 5 theta. That's real, that bit's imaginary, isn't it? So we've got 5 cos to the 4 theta sine theta. This one here is imaginary, so minus 10 cos squared theta sine cubed theta, and the one on the end's imaginary as well, plus sine to the power of 5 theta. And like last time, again, we've got to do some cos squared, so 1 minus sine squareds coming in here as well. So here we've got a 1 minus sine squared, but it's squared again, so I've got to put all of that. Here I've just got a simple 1 minus sine squared for that cos squared there. And we've got the sine to the 5 on the end there. I think I'm going to have to square that one time just in case I go wrong. So I've got 1 minus 2 sine squared theta plus sine to the 4 theta. And we're timesing all of that by sine. I think I'll do that in one because I can rub that out. I'll just put an extra power there. I can put an extra power there. And that can come now be a sine theta. Can I do all this in one go? So I've got minus 10 times by sine cubed. And minus minus, I'm going to have to squeeze this in here. So plus 10 sine to the 5 theta. And we've still got that extra sine to the 5 theta on the end there. Right, we must be close now then. So sine 5 theta equals, so how many to the power of 5s have we got? We've got 5 there, another 10 there, and another 1 there. So I've got 16 sine to the 5 thetas. Sine squareds. Sine squareds, I've got minus 10 there and minus another 10 there. So that's minus 20 sine cubed thetas. And then we've just got that little sine theta there, haven't we? So plus 5 sine thetas on the end there. That's the answer we've got. Hopefully that matches. Yes, it does. Yes.